Jeff Brunner here with the ABB HVAC Drives Applications Engineering team, and in this video I would like to go over how to connect to an ACH580 with Lonworks using the FLON module. And in particular, I would like to introduce the NodeUtil application, which is a PC-based tool. It's free, and it's used to connect into a Lonworks network to do basic device discovery, configuration, and control. The first step in connecting to a Lonworks device is acquiring a suitable network interface, and such a device is available for connecting to your laptop using its USB port, and that's pictured here. This device was originally developed by Echelon Corporation, as they were the original creators of Lonworks, but this interface is now produced by a company called NodeUtil, as they currently own the Lonworks technology. So included in the description below are a couple of links regarding this device. The first is the information page from NodeUtil, which just is an overview of the device itself, and then the second is a link where these can be purchased. And in preparing this video, I reached out to NodeUtil, and their sales team actually directed me to this Mouser page for purchase. And you'll see from this page that it's readily available, and it's actually a very affordable option for getting connected to a Lonworks network. For those of you already familiar with embedded field bus on the ACH580, you can see that this is very similar to the USB to 45 adapter that's so commonly used in those applications. And as one would expect, the interface does require a device driver, and this is also available from NodeUtil, also included in the description below. And I won't go through the installation process itself in this video, but it's very straightforward, and I've done it many times without any issues. But I will make one comment, and that is it's really important that the network interface not be connected to the host PC when you're installing the device driver. If it is, the installation is likely going to hang up and then need to be aborted. And then once the driver is installed, you'll be able to see the attached drivers, and these are visible in the host PC's control panel, which I'll demonstrate on the next slide. So here I've got the control panel for my laptop already open, and with the driver installed, you'll see that there's this option to display Lonworks interfaces that becomes available. And if you click on this, another window will open up and it will display the Lonworks interfaces that are currently attached. And of course, I don't have any attached at the moment, but I do have my adapter on hand. And so as I plug this in, you will see that it populates in this window. And then if you select on this interface, it becomes active, and you can see all the information about the attached network interface. As well, there's some additional test features that are across the top, which we're not going to go into in this video. So now that we've got a network interface connected and available on our laptop, we'll next need an application that can communicate with a Lonworks device. And while there are many high-end Lonworks applications available for purchase, which can be used to fully commission and maintain a building's network, there's also a simple application for just testing single Lonworks devices, and the best thing about this application is that it's free. This application is called NodeUtil, and it's a Windows console application also available from NodeUtil, and the list of the available commands in this application is shown here to the right. And it's downloadable from NodeUtil's website. And once downloaded, simply unzip it to a known location and create a desktop shortcut. And take note, though, that the first time you use it, you may get an error indicating a necessary driver was not found. And to fix these, you'll need to update the path environment variable. And I'll go through an example of how to find this. So you start by selecting the Start menu and searching for Environment. And then this option to edit the system environment variables will become visible. And we'll say, yes, we want to make advanced system settings. And then the system properties dialog will pop up. And down here at the bottom, you'll see a button for environment variables. So we'll click on that. And now we see here what the environment variables are that are available. And under system variables, you'll scroll down and you'll see this path variable. And so select it, select edit. Here you'll see items that are already in the path. And here you can see I've already added this path to the drivers. But if you don't see this here, you'll say New. And your window will open up here and give you the option to add it. And so you simply add in this path, and then you can back out. And then that should cause your NodeUtil application to start normally. So next, we will launch a session of NodeUtil, and we'll view the connected network interface as a first step in learning to use this application. I'm on my desktop here, so to launch NodeUtil, I'll simply double-click on it. And you may get this warning. If so, I'll just run anyway. And here is the basic main NodeUtil window, and I'll expand this to get rid of the desktop clutter. And at the top, you'll see some really basic information about the NodeUtil, including the revision of the release. And there's also a message indicating the presence of a TP-FT10 network interface. And just note that if no interface was detected, the application will not launch. So this shows all the available commands, which are described really well in the documentation that comes with the application. But for the purposes of this introduction to NodeUtil, we'll just start with the basics. So reviewing this list, you'll see the command for listing the devices that have been detected. And so let's try this command. So at the prompt, we would simply enter L. And here we see that the list only includes the network interface because that's the only device that is so far connected to the network. So next, let's connect an FLON module and get it to register on the network. Okay, so I've got a demo case here for a 580, and I have installed an FLON adapter, and I have also connected my network interface to the FLON adapter, but I have not yet registered it in the list. So if I refresh my device list, as we learned in the last slide, I still see the only thing that's visible is the network interface. So what you typically do, and what you do with all of our devices for Lonworks, is there's a button that's included on the device. It's called the service pin. And when you press this button, it causes the LON module to send out its identifying information, which then NodeUtil will pick up. So I'm going to press the service pin. Okay. And you can see that now the FLON module has identified itself to NodeUtil. Now if we do our device list again, which I'm going to enter L, we see now that there are two devices present, our network interface and now our FLON module. So the next thing we want to do is switch over and talk just to the FLON module. And so if we go to this command list, we see this G, which is the command to go to a device. And so I'll select G, and down at the bottom, it says, well, which one do you want to go to? And currently it says 1, which is the FLON module, so we'll select it. And now we have switched to a different set of commands, which are specific to a particular device. And so the first one we'll do is simply show what the module status is. And we can see down the list that there is a command S, which will cause the device to report its status. So we will enter S. And here we see some statistics with respect to the device and its status. And so we can see that, for example, the last reset was caused by a software reset. We see some message counts. And most importantly, now we see this device state, which is currently unconfigured, although it's online, so I'm communicating to it. And then we have the option here to clear the node status, and in the braces, N is active, which says don't clear it, and I don't want to clear it, so I'll just say enter. And now I'm back to the command prompt. And so the first thing we'll need to do before we can take our next step, which is going to be to actual issue commands over Lonworks, is we need to switch this device state from unconfigured to configured. And so back up in the list, I will refresh the list. So if you type H, it puts the list up again. And now we see that there is this M, which is how you can change the device mode or state. So this is what we want to select. So I'll say M. And then I want to actually do a state change, which you can see here in the options is S. So I will enter S. And now it says, well, what do you want to switch it to? And I'm currently in the unconfigured state. I want to switch it to the configured state, which would be C. So I'll enter C. And now it says that it's changed the state. So let's refresh the status for the module. So we'll enter S again. And now we can see that our device state is switched to configured. So now we're in a position to actually command network variables over the Lonworks network. But before we do that, there's another piece of information I want to show how you can get out of the module, and it's called the external interface file, or XIF file, which is a resource file that is available on our website. But the most important thing to know is that you can also extract it from the module directly. So on most higher-end commissioning automation applications, this XIF file is a way that in an offline manner, device information can be pulled into a network that's under design. You can find out what network variables or what data is available in that device without having to be connected to it. So that's what the purpose of the XIF file is. So I want to go through the process of how to extract that from the module using NodeUtil. So let's start by first refreshing our command list and reviewing this list now in preparation to generate the XIF file. We scan down the list, and appropriately the command is X, create device interface file. So we'll select X, and now it's reading this self-documenting information out of the device, and this will take a couple of minutes, and then we'll get the option to save it. And this is where it's important to recall where you are running the NodeUtil application out of, so where you unzipped it and created a shortcut to the executable, because that is where the XIF file is going to be stored. And then we'll go through some of the other documents that are useful in using the XIF file to ultimately get to the point where we're going to command some network variables and control the drive. So here we have the option to name the XIF file, and we will just call it FLON, and hit save. And now here's all the information that is being written out to that file. And we won't get into a lot of detail on what the overall format of the XIF file is. That could be for a more detailed video that we're going to go into for this. So now let's switch over to the directory where it's stored, and we can see here. So this is where I unzipped, and this is where I'm running my NodeUtil executable from. So here we see the XIF file, which we just generated. So we can open this real quickly. And so here's a whole lot of information, and it's going to have all the different network variables that are supported and a lot of other information that we're ultimately going to need to pick the network variable that we want to control over NodeUtil. And all the information that we're ultimately going to need is in this XIF file. So let's stop there with respect to the XIF file, and we'll come back to it, because I'd like to then look ahead to where we're going to get the information we need to actually do the control we want to do. And so let's go to the FLON manual for the drive, and let's scroll down and look for the network variable that we want to use to start and stop and set reference in the drive. And I happen to know it's this NVI drive speed set point. So let's navigate over to that. And so here is, in our manual, the definition for this network variable. And it consists of two portions. There's the reference, which is this value portion, and then there's the state. So that's going to be the start-stop. So the start-stop and reference in Lonworks are both controlled with this single network variable. And so it's this network variable name that we need, because what we'll do then is go into the XIF file, and it's going to give us the network variable index, so the number that we need to control it using NodeUtil. So the other document I want to draw your attention to, and I'll include links to all of these down in the description, is this network variable type master list. So this stands for Standard Network Variable Type Master List. And if you ever talk to somebody with a Lonworks background, you'll hear them use the abbreviation for this. They'll say SNVT. What's the SNVT type? What's the network variable type? And if we go back to the manual, you see that this network variable type is SNVT switch. And so if you go to this master document here, this master list, it is going to have all the details you need to know how to command a network variable of a particular data type. And so here, if we do a search on SNVT switch, it will jump ahead to the definition for this network variable type. And in here is the general overview. And it's going to say that it's a percentage value and it's a discrete on-off. And so here we'll enter a percentage for speed reference or frequency reference, and then we'll use the discrete portion of it for on-off. And so the important thing to recognize is that it consists of two fields, a value field and a state field. And here's the details of that. So the state field is easy, that's just 0 or 1. But here the resolution for this percent is actually in 0.5%. And so The values that we'll enter will be 0 to 200 because it's 0.5% increments. So that's the information we need to control the network variable. So I wanted to show you how to use these two documents to get the information you need then to ultimately go into the XIF file to get this information. So now we can go back in here and we can look up NVI DRV speed. That should get us close enough. Okay, and so now we have found in the XIF file, we have found this network variable. And the important piece of information we need here is this index. So its index is 28. And so in NodeUtil, actually, this is the only reference it wants. It wants this numeric reference to command a particular network variable. And for the purposes of this video, as a bit of an introduction for just doing the basic, can I talk to the drive over Lonworks? Can I do a start, stop, and set a reference? This is the only network variable that we need. Now, in the next step, we will go and actually do the control of the drive. And I'll pull up a panel at the same time so we can do a side-by-side and actually see how the control is being done. So that'll be the next step. But before we begin control using NodeUtil control of the drive, we first have to make sure that the drive is properly configured for the control over Lonworks. So here I've brought up the control panel for the ACH580, and we will go into primary settings and get it properly configured for the start, stop, and the reference to be over Lonworks. So here in primary settings, start, stop, and reference, we will do the primary auto control location. And in here we see we have start, stop, and direction first, and this is set up now for the default, which is DI1. So we'll select this, we will scroll down and now select field bus. So this is for the field bus adapter, and in this case, this is Lonworks. Next, we will proceed to the reference setting, and here we see the default, which is AI1. We will go in here and change this to be also from the field bus. And so now the drive has been properly configured for start, stop, control, and reference to be over Lonworks. And as long as we have the panel up here, let's go into the parameters themselves, and let's take a look at group 51, which is where the module-specific settings will be visible. So we'll scroll down first to group 50, and we will see here that we have at 5001 enabled the field bus adapter. That's step number 1. And in group 51 is where the module-specific parameter settings are visible. So at 5101, we'll also always identify the module type. In this case, it's Lonworks. For Lonworks, 5102 is the node state. And here we see that it's configured and online. And this is what we earlier made sure to establish using NodeUtil. And then the next 6 parameters that I want to point out here are showing what the neuron ID is for the chip associated with this particular Lonworks module. And so this neuron ID is very similar to the MAC ID for an Ethernet module. So there's 6 different parameters which map directly to the 6 octets that are associated with a neuron ID. And so this neuron ID, it's not printed on the module itself, but it's visible in NodeUtil when you first press that service pin button and identify the device. This neuron ID is visible, and so it's a way that you can cross-reference a particular module with the particular device that shows up using NodeUtil. Because with NodeUtil, you could, if you wanted to, do multiple devices on the same network. In our case, this is just point-to-point, so it's implicit which module it is. But if you had multiple modules online, you could use this parameter and the node ID that's published in NodeUtil and determine which module you were looking at. So now that we have properly configured the drive for control over Lonworks, let's proceed now to our actual session of NodeUtil and do that control. Okay, so here I have started NodeUtil alongside an ACH580 panel, which is connected to my demo case. And so let's confirm our device list in NodeUtil. Okay, we still see the network interface, and we see our FLON module is still at device ID 1. So let's go to device 1. Okay, so now we are active again on the FLON module. And if we recall the list here, one that we haven't tried is actually updating an input network variable. And of course, we learned in the previous slide that the network variable of interest for us was going to be 28. And so what we want to do is update an input network variable. So we'll say U for update. Then here's where it wants to give us an index, and it's already set to 28 because I did this already in preparation for this video. So it remembers the last one I updated. So 28 is the network variable of interest. And so here we see network variable 28. It's 2 bytes, as we also learned in the previous slide. So we know that one portion of it is the frequency reference in 0.5% increments, and the second half of it is the start-stop state. So let's just start with the frequency reference, and you'll see here that it's actually in hex. So let's bring up our hex calculator real quick. And so we want, let's say 15 hertz. So that's 25%, but it's 25% times 2 because it's in 0.5 hertz increments. So let's put in 50. And we see that's a hex value of 32. So here for the data, we'll put in 32 for the first field and then 0. So we won't start the drive. Let's just therefore send just a frequency reference and see if it comes through. And it does. So 25% is 15 hertz. Likewise, we could change that to 50%, which would be 100 decimal. So we see that 64. We could have just doubled the hex value. Okay, so we can do update again. Network variable 28. This time we will put in 64 space 0. And we see our reference gets updated to 30 hertz. So now let's go ahead and toggle our start-stop state. So now we'll say update network variable 28, and we'll repeat the same reference, 64, but this time we will change the state from 0 to 1, and we should see the drive start, which it does. And we see it's ramping up to the set point. And so similarly, now we can update 28 and this time say C8, which is double 64 in hex with 1. So maintaining our run state, we see the reference gets updated to 60. And now we're ramping to 60 hertz. So now we will say update and say 28. And now we can read C8. Let's just say 0. So this will stop the drive, maintain the reference. So now, since we're in here, let's pull up our XIF file again and just go ahead and look at a different network variable. Let's look up, I'm going to do a search on DC bus. And we see, okay, so here's a network variable with an index of 53. So let's go ahead and refresh our list. So we had been doing an update for an input network variable. So input is from your client down to the drive. So that's the reference direction for Lonworks. So an output is data from the drive up to the client. And so now we want to poll, and we said, so poll, and now it says give me an index, and we said the DC bus voltage was 53. And we come up and it's an integer number, so it's 345.6. My guess is it's going to be times 10. So let's go over to the keypad and pull up DC bus voltage real quick. It should be 111. And yeah, we see that that's DC bus voltage multiplied by 10. And so similarly, let's change update 28. Let's go back to 30 hertz. So that it was 64 and 0. We see our reference changed to 30. That's in the upper corner of the panel. Now we'll start the drive. So we'll say update 28. We'll maintain that same set point of 64. This time we'll change the start-stop command to start, and the drive will run. So let's just take and look up one more network variable. So let's pull up our file again, and let's do a search on frequency, F-R-E-Q. And here we see another network variable, output frequency, actual, and its network variable index is 64. And so here again we can poll, so P, network variable index 64, and it comes back with a value of 300. And we can see that that is our output frequency times 10. And so we'll close this out by doing another update.
and we will go to 0 for the reference, 0 to stop, and our set point goes to 0, and we stop. So that's just a basic set of network variables that you can very easily read and write if you're just trying to prove out your configuration of the drive, your connection to the module in a real simple pre-commissioning opportunity when you're going to start up a drive. So that concludes this presentation on how to connect to an ACH580 over Lonworks using the FLON module. And I'll just like to summarize the steps that we went through in this presentation. The first step in connecting to the Lonworks network was to acquire this USB to LON network adapter. And then to support its use on your laptop, we had to install this driver, which was necessary to support any applications that use the adapter for Lonworks. And here we learned about the NodeUtil application. And then with the NodeUtil application, we learned first how to discover the FLON in the network. And that was just simply pressing this service pin button, which would announce the presence on the network of the FLON module. And then once registered in NodeUtil, we could query the status of the device and then update its configuration so that we could put it into a state where we could do the control over Lonworks. We learned how to generate this external interface file, which was a necessary resource in understanding what network variables were available and how we would access those to do the control. And then finally, we needed to configure the drive itself for field bus control. And then once it was properly set up, we learned which network variable it would require to do this control. And we learned it was a single network variable called NVI drive speed set point. And that with this single network variable, both the set point and the start stop would be controlled. And with that, I want to say if you have any questions, please don't hesitate to reach out to your local ABB Drives rep or call the ABB Applications Engineering team. Thanks for watching.